हेलो। मेरी आवाज़ आ रही है सबको? हेलो। हेलो। एम आई ऑडिबल? हेलो। Okay, good evening. So, in today's class, we will look at arrays and pointers, a very important concept from the perspective of interview. So, we will start with arrays first, and then we will go with pointers, and then we will see how arrays are linked to pointers. Okay, so suppose you want to store 100 integer variables in your program, and if you have to declare each and every individual variable on your own, it will be very difficult for you. Plus, you will not be able to remember all 100 names, right? So, if you want to store similar values and you want to store multiple values, okay? So, suppose you want to store 100 integer values, it is not feasible to store it in 100 different variables because it will be difficult to create those variables manually and it will be difficult to remember their names. And for that, we have arrays. So array is used to store multiple items of same data type. I want to store 100 float variables, I can use arrays. I want to store 200 double variables, I can use arrays. Okay, so array is used to store multiple values of same data type. Okay, very simple. Now, array is a very special data structure, and what makes it special is its two properties. First one is array stores the data in contiguous memory location. Okay, so if I am storing three variables, they will be stored continuously. We will look at it in our next slide. The second is array itself stores the address of 0th index. Okay, so array stores the address of its 0th index. What is index? We will look it in our next slide. So we know that array stores multiple values of same data type. So how we make an array? We specify what kind of data we want to store in an array. We are storing int. Then we can give any name to our array and how many values I want to store. I want to store 5 values. Okay, so this is how I can declare an array. I can also give the value while declaration. So int array, I'm telling I need to store 5 values and I'm giving those 5 values here in the curly braces. What will happen now is it will create a space for 5 variables and each block will contain those numbers. Now every block is known as an index. Every block is known as an index, and the first index is always starts from 0. In array, the first index always starts from 0. So we number the blocks in an array Okay, and the first number is always 0. So 0, 1, 2, 3, 4. So this is how we number the index. So this is index 1, this is index 0, this is index 1, this is index 2, this is index 3, and this is index 4. So every individual block where a value is stored is an index. Okay, so this is how we declare an array. How do we access the elements of an array? Okay, so now suppose I want to change a value, I want to print something. How do we do that? I can simply do that by writing like this. I am specifying that I want to do something with array index 3 and I want to assign a value 10. Okay, I want to assign a value 10 to an array index 3. So what will happen? At array index 3, the value will be replaced by 10. Okay, if I want to print the elements of an array, I can simply write like this. Okay, I've used the format specifier for integer, and array of second index will be printed. So on second index we have value 3. So this will print 3. Okay, now here we saw that we assign the values while declaring the array, but usually when you solve the questions of array, the size of an array is very large. Okay, so it is not possible for us to give value like this every time. For that, what we can do is we can use loop to assign the values. So in the loop we start with 0 because the first index which we are handling is the 0th index, and we are going less than 5. So if the size of an array was 5, the last index will be 4 because we are starting from 0. Okay, so the last index will always be 1 less than the size of the array. So we start with 0th index and we go with less than 5 and I plus plus. So what will happen now? On every iteration, I will be incremented. So starting with 0, 0, 1, 2, 3, 4. And so I will assign the values at every index. So what will happen? For array of 0, I will assign 0 multiplied by 3, 0. So on 0th index, we will assign 0. When I will become 1, we will assign 1 multiplied by 3, which is 3. Okay, so this is how we can assign values in an array. Now comes the real question. I said that array is a very special data structure, and it is because of its two properties, that it stores the values in a contiguous memory location and it stores the address of its 0th index. All right. Now suppose I create an array of size 10,000 and I randomly pick an index to assign a value. So I'm using the index value 6854 and I want to assign a value 816. Now what do you think will happen? I have a array of size 10,000 and I want to access 6854th index. What do you think? Do what do you think that if does array actually travels till this index? So does array go one by one, 0 to 1, 1 to 2, 1, 2 to 3, 3 to 4, 4 to 5 till 6, 8, 5, 4? Like, do you think this will happen, that it will jump index to index, and when it will reach this particular index, it will assign the value? If this happens, array will be one of the most inefficient data structure. Okay, if this starts happening, that if array jumps from one index to another, it will be one of the most inefficient data structure, but it is not, which means it doesn't jumps from index to index. Okay, it doesn't jumps from index to index. It actually calculates the address of that particular index directly. To access a value, our system needs the address of any value, right? To access any value, our system needs the address. So if I want to access the value at 6854 index, I just need the address of this 6854, right? And how does array calculate that particular index, right? How does array will be able to calculate the address of such large index? For that, the array uses a very simple formula. We know that our computer is excellent in performing any type of calculation, right? It is very fast. So instead of jumping from index to index, it just performs a very simple calculation, and through that it is able to calculate the address of any index we ask. So what is that formula? So if I want to find the address of any nth index, n can be anything. So it needs the address of 0th index plus n multiplied by size of data type. Okay, this is the formula used by the array to calculate the address of any index it wants, and it happens very quickly, right? So because of this formula, array doesn't jumps from index to index. With the help of this, it can calculate any address. So we will test this formula with the help of an example. Now suppose I have an array. Okay, in this array I have total 10 elements, and let's assume that the first address of 0th index, the address of 0th index is 100. We are assuming that the address of 0th index is 100. Now if you remember, I told you about two properties of an array. First one stores data in contiguous memory location, and array itself stores the address of 0th index. So array just stores the address of 0th index, and with the help of this it can access any other element. So using this, the formula works properly. So the address of 0th index is 100, which is stored by the array. And let's see, I want to calculate the array of 7th, address of array of 7th. So that means my n is equals to 7th. Okay. So address of 0th index is 100. Now array stores the element in contiguous memory location. So if the first element is 100, and since an integer takes 4 bytes, the next integer will be stored at 104. It again takes 4 bytes, the next integer will be stored at 108. So this is a contiguous memory location. Okay, so 100 plus n, we have n equals to 7. 7 multiplied by size of data type. What kind of data we are storing? Currently we are storing an integer. So the size of an integer is 4 bytes. Okay, size of an integer is 4 bytes. If I solve this, which means I get the address as 128. That means the 7th index is at the address 128, and if you see here, the 7th index is at the address 128. Okay, so that's how array access any of its index. Array doesn't need to store all the elements. It just stores the address of 0th index, and all the elements are stored in contiguous memory location. Because of these two things, this formula works perfectly fine, and with a very small calculation, it is able to calculate the address of any index it wants. So this is how array access any elements, and this is how it is a very efficient data structure in many cases, right? So array doesn't jumps from index to index, it just uses this particular formula to access the elements, right? Okay, let's move on to next topic. Next we have 2D array, right? So we have already studied array. An array is a collection of multiple elements of same data type. A 2D array just stores the data in 2 dimensions. Okay, so like this. Okay, so to declare 2D array, we have to declare like this. We give two numbers this time since it is a 2D array. The first number is for rows and the second number is for columns. Okay, so these are my rows and these are my columns. So this is a 2D array, right? Now, when we look at 2D array, we visualize it like this, which I have drawn here. But in the computer's memory, the computer doesn't know any structure like this. Okay, so this is the kind of structure which is helpful for us to visualize a 2D array. But this is not how 2D array is stored in a memory. In the memory, this array will be stored as like this simply. Okay, so this whole data is stored linearly. This visualization is for us, but the actual storage happens like this only. In computer, we don't store 2D arrays like this. Okay, if you want to know how do we access the elements in a 2D array, like how computers access, first let's see this particular part. Here I want to assign values in a 2D array. Remember that to travel in a 2D array, to print values in a 2D array, to access values in a 2D array, we always need nested loops. Okay, so the first loop is for rows, the second loop is for columns. Okay, and this should be R and C. Okay, and like this we set the value. Okay, so like we did in case of pattern printing problems, it is similar. The first loop is for rows, the second is for columns, and then we access any value. Now when we do this, we always imagine our array to be like this, but I just told you that in memory the 2D array also looks like a linear data structure. It doesn't have any structure like this. So how does computer know which element to access whenever we write? So this is my row 0, this is my row 1, this is my row 2, this is my column 0, column 1, column 2, column 3. So if I write array of 1, 2, that means row number 1, column number 2. So row number 1 is this, column number 2 is this, so 5. So this is actually 5. Now I can visualize this, so I am able to tell this is my element, this is my row 1, this is my column, and this is the element. But in computer there is no row, there is no column, but still computer is able to give you the correct value. How? If it storing the value like this, how is it giving you the correct value? For that, it again uses a very simple formula. I'm giving you the formula. You can try to apply it and you will be able to find that how it gives the correct answer. So when I write something like this, the computer figure out how many number it needs to skip so that it will give the answer. For example, 813258, 813258. These many numbers should be skipped so that I can get my answer. So if we are able to figure out how many numbers we need to skip, we will get our answer, right? So what computer does is number of elements to be skipped. So it just calculates this part and it is able to give the correct answer. This is a very simple formula which it uses to figure out how many numbers it should skip to find the correct answer, right? So C is the total number of columns present. Total number of columns present is 4. I is the number which I have written to excess. And J is the number which I have written to excess. So C is the total number of columns initially. I and J are the numbers which I have used to access any particular elements. So this is 6. So this will tell compiler that you need to skip 6 numbers before you find your answer. So 1, 2, 3, 4, 5, 6. We will skip 6 numbers and then we will get our answer. This is how 2D array calculates its correct index. Okay. So this is the basics of 2D arrays. Let's move to next topic. Next, we come to pointers. Okay. Now, a pointer is a variable which stores the address of other variables. Okay. Whenever we create a variable, every variable stores the value. Okay. So what will happen? A memory for C is created, and at this particular space we store A. Okay. And suppose it has any address 1, 2, 3, 4. It can have any address 1, 2, 3, 4. Now a variable normally stores a value, but suppose I want to store this address somewhere. Okay, I want to store this address somewhere. I can't do that in any normal variable. For that I need a special variable which we call as pointers. So to declare a pointer, we use this asterisk symbol, then name of the pointer variable, and then address of C. So this operator denotes address of C. That means I want to store the address of C in this pointer variable. So what will happen? A pointer variable will get created which is storing the address of C. Address of C is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 will get stored. Okay. So this is a pointer variable which is storing the address of another variable. Now if I print P, so I will get the value which is here inside P. I will get hash 1, 2, 3, 4. But if I print asterisk P, now note that when I used asterisk here, it was just to denote that the variable I am making is a pointer variable. But here I am using asterisk with my pointer variable, which means it will act as a dereference operator. Okay, this asterisk will act as a dereference operator. So what do we mean by dereference? Dereference means it will give the value at that particular address. So P is storing the address 1, 2, 3, 4, and the value at that 1, 2, 3, 4 is this A. So this will print A. So dereference means you are moving from reference towards value. Okay, you are moving from reference towards value. So P was simply whatever we stored inside P, but dereferencing means P was storing an address, and from that address we need towards its value. So we move towards its value, which is A. So star P means A. Or you can essentially think that star P and C both are same, because if I print C, it will print A. If I printed star P, it printed A. So both are exactly same. If I try to change it, if I write star P equals to 6, or since it is a character, let's give a character only. Suppose if I write star P equals D. So since I said star P and C are same, so star P equals to D is similar to C equals to D. Which means writing this statement will change the value here because I'm dereferencing it. So basically I will change the value at this particular location. Okay, so this is a dereference operator in case of pointers. Right, so just remember that pointers are variables which stores the address of another variable. So if this part is clear, we can move to double pointers. Let me create that example again. So we created a space for this C variable, which was storing this A character. Next, I created a pointer variable, which was storing the address of C. So if the address of C was 1, 2, 3, 4, this P pointer will store this 1, 2, 3, 4. Okay. Now, this C was a variable, a normal variable, and its address was stored by a pointer variable. Now this pointer is also a variable, right? It is also in the memory. So it is also a variable, and hence it also will have its address. So suppose this particular block has an address of this. Okay, since pointer is also a variable, it will also have an address. So that means every individual which is in the memory will have its address. Now a normal variable's address was stored by a pointer variable. But what happens if I want to store the address of a pointer variable? Since pointer is not a normal variable, it is a special type of variable. And if I want to store its address somewhere, it can't be a normal variable, right? So address of C was stored in a pointer variable. C was a normal variable, right? P is a pointer variable. So if I want to store its address, I will have to create a very special pointer, which is a double pointer. This was pointer which was storing the address of a normal variable. This is a double pointer which is storing the address of a pointer variable. So and how do we create a double pointer? We use two asterisk symbols indicating that it is a double pointer, and it will store the address of this pointer variable. Okay, so to store the address of a pointer variable, we declared a double pointer. Now what will happen if I print C? Very simple. Whatever we have inside C, it will be printed, so A will be printed. What will happen if I print P? Sorry. What will happen if I print P? What we have inside P will get printed. What will happen if I print Q? Whatever we have inside Q will get printed. Okay. What will happen if I print star P? We know that this is now acting as a dereference operator. That means we need to move from address towards its value. So P is storing an address 1234, and we need to move to the value stored at 1234. So 1234 has a value A. So this will print A, right? What will happen if I print star Q? Again, Q and then a dereference operator. Dereference means we need from address, we will move from address towards a value. So Q is storing an address, and we need to access the value at that address. So Q is storing 5678, and what is the value at 5678? 5678 has a value 1234. Right? What will happen if I print asterisk asterisk Q? This time I am using dereference operator 2 times, right? Dereference operator 2 times, which means first we solve it 1 time. So the value at 567, value at Q is 5678, and the value stored at 5678. So Q is storing 5678, and the value stored at 5678 is 1234, which we have seen here. Now this part is solved, so we can say asterisk of P, because 1234 is P. That means I can write star Q as P, and then again one asterisk is left. Now star P, we know star P is A. which means star star q is equals to a. I'm explaining this part again. We are first dereferencing q. So q has a value stored and we need to access that value stored at this. So q was storing 5678. Then I want to access what is stored at 5678. We have 1234 and 1234 is p. So that means star q can be written as p. Then again we have one more asterisk and this becomes star p, and what we know is star p is a. So here I can say that C and asterisk asterisk q and asterisk p, all of them are same, because C is also A, star P is also A, star star Q is also A. That means if I change something, it will essentially change the value here. Okay, it will essentially change the value at this particular point. So this is the concept of double pointers. So this is a variable which can store the address of a pointer variable. Right? Now let's move to next topic. I have written very simple problems. We can discuss these to get a clear idea on what are pointers. I is equals to 3, right? I am declaring a normal variable 3, a pointer j and a k. Okay. J is equals to address of I. So what I will do is I will create I is equals to 3. J is a pointer variable which stores the address of this I. It can be anything. And what I'm trying to do is I'm trying to calculate this expression. This is I asterisk asterisk j plus asterisk j. So this is very simple. You can just expand it to look like this. So I is 3 multiply by asterisk j. Asterisk j means we are using dereference operator. So j has an address xyz, and what is the value at xyz, which is 3. This is 3. Again we are using asterisk z, which is 3. Okay. So 3 3s are 9 and 9 plus 3 12. So this will give you the output 12. Okay. Okay, this is 3 3 3s 9 asterisk j. We have yeah, take. Okay, this is fine. All right, this is one of the problems. Let's move to next problem. Look at this problem very carefully. I have I equals to 10. Then I'm calling this function foo, where I'm trying to write address of I plus plus. And here I am receiving it as a pointer and I'm trying to print the asterisk p. Okay. Now this program might look normal, that okay, this is our pointer. I'm trying to pass the address of I here, But actually, here we have an issue. What is the issue here? If you notice here, I'm trying to use this expression, right? I'm trying to use this particular expression, address of I plus plus. Now, the one thing is, I am trying to increment the address. Okay, the first issue is I'm trying to increment the address and I want it to be stored in P. What will happen if I have I which has 10 stored, suppose at an address 256? Okay, suppose this is the address. I'm trying to increment it and I want to send it to P. So I'm trying to access another address which may or may not be part of our program. Okay, so I'm trying to access a different memory. So it is possible, it is not necessary that it will happen, but it is possible that my program will crash here. Okay, now the next issue. The next issue is this particular part is not modifiable. We can't modify this. This is a temporary value, right? What happens is when we write like we actually stores this particular part inside P. But alone this, if I'm just talking about this address of I, it is not anything. It is just a temporary storage space. It is just a temporary storage space. Similarly, like if you do int x equals to 7, the 7 itself is nothing, right? The 7 itself is nothing. If I try to write 7 plus plus, it will give me an error because this 7 is actually a temporary storage. X is a permanent storage, not 7. So the value on the right side of this equal to in this case is not modifiable. We cannot modify this. Same way, what I'm trying to do here, I'm trying to modify something which we can't modify actually. So this will give you a compilation error. Okay, so we will not be able to call this function. I gave you two reasons, because we are trying to increment the address. This address may or may not be part of our program. So our program can crash. And even if it doesn't crash, this particular value, we can't modify it because this is a temporary storage, right? So this is our problem too. Now let's look at this particular question. Before before I start explaining, I will give you 10 to 20 seconds or maybe 30 seconds to figure out the answer, and then you can match if your answer matches with mine or not. Okay, so I'm giving you 30 seconds. Just take a look at it. Okay, I hope you were able to solve this. It's a very simple problem, but it is very interesting. So I have array of size 5. So let me draw it. I have an array of size 5. I have three variables I, j, m. And now we will assign some values to them. First, I am using plus plus on array of 1. This is my 0th index, this is my first, second, third, fourth. Plus plus on array of 1, which means this value will be incremented first and will be assigned to I. So we will increment this value and then we will assign it to I. Okay, this looks fine. Next, we have a of 1 plus plus. This is a post increment in this case. That means we will first assign the value and then increment it. So at array of 1, we have 2. And then we will increment that value. So this will become 3. Right? Next, I have a of I plus plus, which means I will first resolve a of I. A of I is 2. That means array of 2. Array of 2 means 15. And I had I plus plus. That means I will increment the value of I as well. Okay. So first array of I was resolved. Array of I was 2. So I just used array of 2, which was 15. And then I incremented I because I was using I plus plus. So I value becomes 3. So I, j, m, this will print 3, 2, and 15. Okay. So these were some of the problems, and these are those kinds of problems. If you practice these kinds of problem more and more, the conceptual knowledge of any programming language will get stronger, right? So I would suggest you to practice output based questions in C language, based on pointers, based on arrays, based on operators, so that the more you solve, the more clear you will get on these concepts, right? And as I said in the last class, I'm not able to look in the chat, but if you have any doubt which you have sent in the live chat, always share them once the live video is uploaded so that I can look at them and I'll answer it. Okay, so this was all for this particular class, arrays and pointers. In the next class, we will look at structure, unions, and those kinds of things. So that's all for now, and that's all.